The ice which will be the dirty in the daytime, that will be broomed in the night. So next day it will be fresh.
And they are also brought a snow making machine.
We are having the 3 snow making machines. So we will make a machine at a spot. Even on Kailash we are going to have a near about 300 mm thickness of ice. So that load is also considered in the design.
Now ferrocement design and planning comes in picture. There were some requirements and constraints for the design. Shape, as you have seen, shape is important. Just erecting any mountain is not desirable. That shape has to be there exactly as per the photograph. It should look like that same photograph. That was the most important requirement. Structurally, it has to be safe because people will be going around. So it has to be safe. Space below has to be utilized. Otherwise, it would have been very easy. Just make a mountain of masonry or stone and bring the shape. But it is not the case. That space below should be utilizable. And one more constraint is there because they had done the flooring. And below flooring, they have run some pipes.
Yeah, we are having PEX pipes inside the floor to run a glycol, which keeps the floor cool. That is the main, actually, we can't disturb that pipes. The PEX pipes of 12 mm diameter, we will running the glycol liquid through the pipes because glycol liquid keeps floor cool.
Ethylene glycol?
Ethylene glycol, right.
So,
Because of that only we can't drill anything in the floor. Above that we have made one raft of 200 mm thickness, both side reinforcement, and on that reinforcement we have built the structure without any puncturing. We did only rebarring. Pardon?
Temperature outside the tube, glycol tubes, or in the floor?
It will be minus 20 degree.
Minus 20.
Yes.
Glycol freezes at?
Minus 13. Minus 13.
so we had a limitation. We cannot drill the hole deep inside. Maximum 50 or 60 mm. He said that you cannot drill the hole more than that. So that constraint was also there. So our structure has to be self-standing. That was a requirement. And without taking any support from the structure, because they have erected the structure, but we cannot take the support of that structure for the shade. So it has to be self-standing. That was another requirement. Then how it was designed? Firstly, we marked all the contours on the floor with full scale, required scale, because that 14 meter end and length 50 meter or something like that. So all the contours were marked on the floors. Grid, we marked a grid of 300 mm by 300 mm. So when all the contours were marked, I found that between the 300 mm, contour lines are straight. So it is clear that if we erect and made the straight lines between 300 mm, we will get the exact form of the contours. So we decided to go that way. Initially, supporting structure is required. We cannot just make a ferrocement slab or wall of that 30-40 mm thickness and give the shape. It is not possible. So supporting structure has to be there because the span, widthwise span was also I think about 15 meter or so. So naturally